Left of x. This video is designed for students in the Dirac Calculus 1 class. Part 1. In order to explore what left of x does and how to write its formula, we will use a slightly silly story about a man called Bob. Bob loves to check the speed of his car, but he can't spend all his time doing so. So he starts a stopwatch and decides to check the velocity every few minutes. At any moment, there are at least two questions we could ask. What time did Bob last check the velocity, and what was the velocity when Bob last checked? Left of x answers this first question. Given the current stopwatch time, what was the stopwatch time when Bob last checked the velocity? Let's make sure you understand the dependent values of the function left. Assume that Bob begins his stopwatch, and then 3 minutes later, he starts checking the velocity every 5 minutes. So he checks at 3 minutes, 8 minutes, 13, and so on. Can you evaluate the function left for these independent values? Pause and do this yourself. Now compare your answers. Left of 6 is 3, because at 6 minutes on the stopwatch, the last time Bob checked the velocity was at time 3 minutes. Left of 8 is 8, because at 8 minutes on the stopwatch, the last time Bob checked the velocity was right then, 8 minutes. And left of 17 is 13, because at 17 minutes on the stopwatch, the last time Bob checked the velocity was at time 13 minutes. Make sure you check your other answers as well. Pause to do so. There is something really important you need to notice about left of x. Both the function's independent values and its dependent values are values of time. We didn't use any velocity information. In fact, on any rate graph, the entire y-axis has nothing to do with left of x. In other words, left of x doesn't take in a time value and give a velocity value. It takes in a time value and gives another time value. The independent value for left is current stopwatch time, and the dependent value is stopwatch time when Bob last checked the velocity. So as the independent value x increases, the dependent value left of x always returns the time of Bob's last check. Pause and replay part 1 until how left of x works is very clear to you. Part 2. Now let's work on the formula for left of x. First, we'll use a specific example. Let's say Bob started the stopwatch, and then 6 minutes later he began checking the velocity every 4 minutes. We want a formula that will create correspondence points such as 8.3 and 6, 13.4 and 10, 15.5 and 14, and 17 and 14. This is not a basic polynomial function like the ones taught in high school. Think about all the time after Bob first checks the velocity as split up into intervals between checks. Our plan for how to write the formula has 3 parts. If we can find the interval the current stopwatch time x is in, we know the previous interval ends with left of x, and we can use that to calculate the dependent value of left. For example, let's say the current stopwatch time is 17 minutes. 17 minutes is in the third interval between velocity checks, so left of x must be at the end of the second interval. So left of 17 is 14. Now let's write a formula to go through those same steps, using bar lengths to represent the quantities. The length of this bar represents x, or the current time on the stopwatch. In our example, 17 minutes. If we subtract the time Bob waited before first checking the velocity, the length of this bar is x minus a, or how long it has been since Bob first checked the velocity. In our example, 11 minutes. Now, if we divide this by delta x, the length of an interval, we get how many delta x's fit into x minus a. In other words, this gives us how many intervals passed up until our current time x. In our example, 2.75 intervals. We have now completed the first step of our plan. In our example, we know that our current stopwatch time x is between Bob's second and third velocity checks. Our next step is to round the number of intervals down to the nearest whole number, which we do by taking the floor of the number of intervals. In other words, this gets rid of any partial intervals and gives us how many whole intervals pass by before time x. In our example, 2 whole intervals. We have now completed the next step of our plan. We know that the value of left of x is the moment when the second interval ends. Now we complete our last step by calculating the value of left of x. If the expression we have so far represents the number of whole intervals, then we can multiply that by delta x, the length of each interval, to see how much time the whole intervals cover. In our example, 2 intervals times an interval length of 4 is 8 minutes. Don't forget, though, that there was already some time on the stopwatch before Bob checked the velocity for the first time. To find the value of left of x, we need to add up all the time the stopwatch was running until the last time Bob checked the velocity. Adding a gives us the value of left of x, in this case 14. We have now built a formula that always correctly calculates left of x for any value of x. Pause and replay part 2 and make sure you understand how it was built. Finally, let's check that our formula for left of x works. In our original example, Bob waited 3 minutes and then checked the velocity every 5 minutes. Calculate the following values of left of x using our formula. Now compare your answers. They should be the same answers that we got using the number line. Our left of x formula is now ready to be used. Left of x.